Hello, James Sylvester from JPS Reliability. I'm also a trainer at RMS at the Reliability Training Institute. What I'm going over today is case study 2. This is case study 2 of 5. So this is another one which is taken from my recently published book, Enhancing System Reliability Through Vibration Technology. So this is a practical case study with all the vibration data and the case study followed through. And again, it's working with the MIRCE Academy, where we're bringing the reality towards the theory and the theory to reality. Working with Dr. K has been great because it's actually enhancing both our work. It's helping me understand more science behind what I'm doing and why I'm doing what I'm doing. And likewise, on the theory side, the doctor's getting to see where the science actually fits into reality. So if you didn't see the first case study, that will be up on my blog and the RMS website as well. That was the electrical motor terminal connection vibration problem. This case study is on a standby motor fan defect. A little bit of background on this one. It's in a plant where you've got two fans about 3 meters apart. Very noisy plant, crushing a product. Everything's noisy and you can't hear much at all. They needed to change one line to the other line. This line had to run for a while because it's their standby line, but due to a problem, they had to swap over. They swapped over, and unfortunately, they actually heard the motor sounding bad straight away. So they called us to go and have a look. This is the initial vibration data. This is the acceleration time waveform. And I must say, the time waveform is where you really should be doing your analysis. This is where all the information about what the machine is doing is at. So here you can see a comparison. In blue is the running unit, which they need to shut the line out to move the line over, and green is the standby unit. So we've got peaks going up to about 29 Gs plus and about 25 Gs minus. And yes, you don't need vibration analysis to tell you it's bad because they could hear it also. But what they really wanted to know was what was causing it, because this was their standby unit. There should be nothing wrong with it. So as well as acceleration, we took velocity and the bearing condition unit, and that particular unit was peak view. And on here, what you can see is the one order defect and exponentially sort of decayed harmonic. So we know that bearing's going bang, 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 and the energy's ringing down. Now that was actually at the outer race defect frequency. So straight away you said to them, yep, you're right, bearing sounds bad, it is rooted, and it's actually got a bearing race defect, highest on the outer race. Lucky enough, they shut the fan down in a control situation, took the bearing there, and we went to have a look at the bearing. On the left-hand side of the screen, we can see the grease. You can see that the grease is contaminated. It's starting to separate within itself. And actually, that there is a picture of the inner race. So you can see a mark on the inner race. And when we looked under the microscope, it's actually got rust in it. So we can see that's forced brinelling. But the data was highest on the outer race. Well, when we looked at the outer race, these dents, they were like craters, you could feel them. You can see here on the picture, we got 3 or 4 together. So that motor had sat there, no one had turned it, and there's vibration in the plant, and it's shaking down, and it's shaking down, and it's causing the forced brinelling. And the little bits of the lines, there's a very slight movement in the rotor, just moving that bearing there. Now, lots of things can cause that. Obviously, lubrication is a big thing. If you haven't got good lubrication, it can amplify the problem, and vibration transmitted. So looking at the whole sort of system, how it's set up, we can say, bringing the science into it, that the failure cause was insufficient isolation of external vibration sources. You can sort of say about the lubrication being contaminated or poor, but even if it's contaminated and poor, if there was no vibration, then that vibration would have caused this rotor to do this, to cause the forced brinelling. Mechanism of failure was forced brinelling, and how it's detected, the mode of detection, the failure mode, was through vibration. You can put in there as well audible noise, because obviously they heard it as well. So the sort of the summary on this case is that transfer of the load and the stresses through the fracture in the foundation generated a mechanism of failure of forced brinelling that manifested itself in the vibration mode of failure. So this was detected, and actually the negative functionability event was prevented. So we prevented an event which affects the functionability of the system. It is managed and controlled. So as a very brief case study, shows you how we can, with vibration analysis, if it's used correctly, how you can detect the failure mode, work out what got on it, stand back and look at it and sort of see what's caused the issue, and then help to resolve it from happening again, because that's what we want to do. So we can help in three main ways. That's upskilling your team with practical mentoring, on the tools training, getting them used to using the equipment in all the condition monitoring technologies, and obviously general maintenance practices, contracted reliability services, and also we can deliver ISO 18436 courses, which are conforming to that, through Mobius and the RMS Reliability Training Institute, and they're either accredited in MIBOC or BINDT. Again, I like to keep this slide in because it shows people the four main techniques and how they're all interlinked, and it's to remember we don't just use vibration, we don't use electrophotography, lubrication, ultrasound. We use all of these plus use human senses and your common sense. Again, that slide is just a little bit about the company, qualifications, where registered, and a bit about background. This is for the MIRCE Academy. Please do go on the website. Try and get in contact with Dr. K. He's very, very, very knowledgeable and extremely helpful. And it is amazing to see how what we do in practical enhances with the science. So that's case study 2. We've got another 3 more to come. So please keep a lookout for them. Thank you very much.